Welcome, everyone. My name is Dominik Holzer. I'm very happy to be your host and your session chair today for our session number 5. I will very quickly share my screen so we can see what this session is all about. There we go. Oh, just need to make sure I have the right screen on there. Yeah, of course, today this session is all about building information modeling, city information modeling. Just confirming, can you see the full screen? Can somebody tell me? Yeah, very good. Also regional information modeling. And to be honest, in retrospect, when I looked at the amount of great papers that we have here today, I would say this is probably a session that will focus quite heavily on the city scale, urban scale and beyond. So we have really an exciting array of papers that we look at today. Just as a summary for the authors that we have today. We have, as you can see here, a list of 12 coming from all parts of the world. Very happy to see that. We have been very glad that we could receive such high quality papers for this session. And quite a diverse range of papers for this session. As I said earlier, so the key, the central topic seemed to have been, at least when we set up this session context, about building information modeling, but as you will see in a moment, we're really going far beyond that. We have quite a number of papers that look at particular aspects of urban design, urban planning from a heritage perspective, from a legal perspective, from a daylight and energy environmental perspective. We have some of these papers really crossing the boundaries between what you would consider urban planning, urban design, AI, performance optimization, building information, and so forth. So there's quite a range of information that we will see today. We have about 45 minutes, so that means we have limited time here to present. That's why I've asked our panelists to not necessarily give us a mini presentation of their paper. You should have all seen the papers on the online. So what we are doing instead, I will give you a very brief rundown of the papers and the key content. And we will then have a discussion among the panelists, and we will then invite you as the audience also to participate and ask questions and so forth. So I'm going to start off with a paper from Anne-Maria Chazzi and Lisa Marie Wessler about OGOS, a tool for visual densification potential. And I think there was work done predominantly, I believe, in Germany and Berlin as one way of looking at how there in the Berlin sort of urban fabric, there are some gaps and potentials for further planning and development and infills. We have a paper by, and I'm sorry if I'm not pronouncing this correctly, Yishi Shia, Nobuyushi Yabuki, and Tomohiro Fukuda about the development of an urban greenery evaluation system based on deep learning and Google Street Views. Again, it's really interesting to see how we are crossing over here different topics. We also have a paper here from Prandeep Alva, Hanjie Lee, Julie Lin, Palak Mehta, Jilin Chen, and Patrick Janssen about geocomputation for district planning and agile automated modeling approach. We have a paper that looks more into daylight and energy in an urban context with the irradiance mapping for large-scale city models by Han Jie Li, Julie Lin, Yi Zhang, and Patrick Janssen. Next, we have a paper from Austria, Flewitz, in the rezoning process, a web application to visualize alternatives of land use planning by Wolfgang Lorenz and Gabriel Wurzer, where we look at some of the context having to do with more user participation in understanding sort of the, in a 3D context, sort of the planning permissions and useful information of how you can make that process more accessible to people, both on the government side as well as private sort of users. We have spatial characteristics, analysis of urban form in macro scale based on landscape pattern indices, Jilun Su and Siju Tong. We have automatic recognition and segmentation of architectural elements from 2D drawings by convolutional neural networks. So there's a really interesting crossover between BIM and AI, and looking at how we can extract some sort of logic or some building systems logic coming out of a AI merger with building information modeling. Then we have probably the award for the most colorful graphics, together with her colleagues. So we have Clara, and I'm sure I cannot pronounce this correctly, Cinska, I hope it's the right name. I believe it's from Poland, with computational methods for examining reciprocal relations between the viewshed of planned facilities and historical dominance, the integration with the cultural landscapes. I really hope you find ways to shorten your titles in the future. Well, that doesn't matter. The colors that just speak for themselves here, and really interesting, quite aligned with the paper that we have next from Pavel Rabinovich, sustainable development of cityscape using the visual protection surface method, optimization of parameters for urban planning. And if I understood this correctly, both of these papers look at how we can understand in a historic context of cities, newly developed proposals, and particularly their height and how that height impacts on the cityscapes. So really interesting work that comes from Poland here. Next, we have the environmental performance-based community development, a parametric simulation framework for smart growth development in the United States. So colleagues from the US, who I believe have found a really interesting way to merge between building information models and environmental analysis on an urban scale, and using that as a planning tool as well. And last but not least, we have a paper that talks about practice quite a bit, and sheds a light and about 4 approaches for the integration of digital BIM processes, practices in architecture projects. And that is by Gilles Hallin, Veronika Bolshakova, Elodie Hochscheid, and Henri-Jean Gless, and Saya Aida. And here again, looking at different aspects of 4D BIM, looking at BIM and the way it's unfolding in practice in a variety of different approaches. So we also have a paper, and I have to apologize from Seng Sang. I think we just had a bit of bad luck with the upload of the video in last minute, but I hope Shen can join us with a bit of insights about his paper as well. I think it also has to do with the cityscape work he has done for Guangzhou. So of course, Shen is also invited to talk to us about his paper. So that was my quick rundown. I didn't want to make this any longer, and as I said, we don't want people to go too deep into into a representation of their papers. Maybe as I promised, I want to start really at the back end, and I want to start here at building information modeling, and really see maybe our 2-3 contributions towards the end. If you wanted to join me in a bit of a conversation about the research related to building information modeling, the way that research that we see in academia unfolding here, how that may influence or is currently influencing practice, and how your particular work might feed into this. Any of the authors that I just listed from the final 3 papers, I would invite to join me for a bit of a conversation on this. Where are our BIM authors? I can also call you out by name if you wanted to. I need to go back into my slide share. And best, I would recommend that you talk to us, so that way we can actually hear you, so it's not just about adding information into your chat.
Hello?
Yes, hello.
This is Veronika Bolshakova speaking from the last paper. The paper presents 4 approaches, therefore 4 PhD dissertations. And they study different aspects of BIM, the programming aspects, the collaboration, the general adoption, and the methods of management and collaboration inside the team. And we got really amazing results for a PhD about BIM adoption, which is really aligned with the works of Mr. Zukar and Kassam, who started BIM adoption global and, the BIM dictionary idea developing everywhere. And we have discovered a very interesting thing. My colleague Elodie discovered that after sending a survey of 800 people to 800 architecture firms, they've discovered that people don't necessarily use BIM for small projects. They can actually use it and find it useful for all kinds of projects. That was a really interesting discovery. Do you have the same impression that people think it might be for only large-scale projects, but actually it works for all the projects?
Thanks, Veronica. Thanks for those insights. We already have a first question actually from one of the panelists, from Patrick, who's asking, when does BIM have too much data? When is it becoming too heavy? It's a really interesting question, given that we are talking in this session about city and urban models with hundreds of thousands of buildings in there sometimes. So, and we are starting that question on the BIM side already. When does BIM become too heavy? Have you, as part of your research with practitioners, have you raised that question with them?
Just a little bit by studying the 4D BIM, and we have discovered that already having the play button, the 3D model, and the Gantt chart together is already too much. People are not able to easily understand the information from the 3D window and the 2D. So the time scale was already too much for non-professionals, and I believe that the paper that mentioned Navis works, so the automatic recognition and segmentation of architectural elements from 2D drawings, they had mentioned that element as well.
Mm-hmm. I'd like to move on and ask one of the authors from the second last paper, either John Boom or Bimal or Joedi, if you wanted to fill in a little bit about how you see that sort of building information context. And again, you went out, you did quite some extraordinary sort of research on how you can break BIM up and make it a bit more permeable. Do you feel it's necessary for BIM, in order to become a design tool, to be broken up, be used against the grain?
So here, I'm Jongbom Kim, and before I explain my thought, here I'm in the United States, Central America. So I have 12-hour differences from Bangkok to here. So it's very early morning, so 5 a.m. And so it's a bit challenging to adjust my time zone. So please understand some skin tone or my pronunciation today. And the research, so what we are envisioning in BIM for city scale, simulation or modeling or visualization is how we use rich information and parametric kind of mechanism in parametric BIM for kind of the future performance prediction or visualization. It's a kind of long time journey for us. So in the early stage of our research, we tried to employ the benefit of BIM for city modeling, city visualization, and simulation. But it was a couple of years back, but we had series of challenges. The level of detail, level of scale, and sometimes, as Patrick asked, the richness of data in BIM side, that was not matching to the requirement for city modeling or city, the kind of community level scale project. So until now, we have investigating the blending between the modeling side and simulation side. So we used the Revit-based, here in the United States, Revit is dominant. It's free for academia. So we relied on that, the BIM authoring tool. environment. And then we investigated beam-based energy simulation or beam-based parametric modeling or rhino grasshopper-based modeling and simulation. And also for the prototype development, we have investigated the C#-based API or IFC-based the data conversion or CTGML.
Thank you, John. We need to speed up a little bit so we get everyone to. So there was actually an add-on question that I have for you, and it was a very good question from Patrick, I believe. So why would you then use BIM for this? There is an opportunity to use C# and to use other tools like the Ladybug or Honeybee sort of plugins, but use them outside of a BIM environment, because BIM can also become restrictive in that regard. As much as it's good for documentation, possibly, but it may not be all that good for large city models and the environmental impact. So why have you chosen specifically to cross it with Revit?
Because BIM has rich data related to building. Building related data is relevant to the future development. All the properties and material information, or also the basic, the building component, the behavior embedded in BIM, that's critical information for future development prediction. So that's the juggling. So BIM data or BIM capability will benefit the future development prediction, but to handle the large scale of city model, it's very, very limited. So two sides.
Thank you very much, John. Thank you. We might come back to your paper later on, but just again in terms of time, we want to move on, and let's see if in my presentation, if I have that correctly. Yeah, I want to jump a little bit here just for the next sort of BIM-related paper, and that's the one with Yang Xiao and Sen Chen and Yasushi Ikeda. I was really pleased to see that somebody is looking at this from a different perspective, because we are to what we typically see in research, because here we kind of see the edges of BIM softening up via an image-based sort of image-based AI interpretation and reconfiguration, you could nearly say, that is particularly aiming at developers, if I understood that correctly. Would you want to talk a little bit about that sort of aspect and why, again, BIM models might be the right sort of interface for this, as opposed to, let's say, simple CAD drawings?
Hello, can you hear me?
Yes, we can hear you.
Okay, good. Actually, Jensen can't be here today, so I'll be the presenter. So basically, this research is based on the statistics of the BIM development in China. So based on our research, we have found that the BIM actually in China is the tool basically to show the 3D model, and to basically is modeled according to the already finished 2D drawings, so which takes a lot of manpower and a lot of time. And sometimes it is so easy to make some mistakes. So, and another perspective is the BIM, the main tool is Revit, which is mainly used, very useful in the big projects, but for the small scale, like individual house or maybe a small building, it is very hard to be applied to, because for the client, they may not be able to see what's the benefit they can get to use the BIM tools. So our basic idea is to decrease the modeling time. So we were thinking about to apply the deep learning, which is the segmentation technology, to recognize the architecture component and the 5 basic categories in the floor plan drawing. So we can locate that, and then after the network can recognize the different components, then it will combine the components together. So we may think maybe this is a more faster process to make a 3D model more quicker. So this is our general idea.
And can I ask you, back to my question, so why would you, because at the moment with the image recognition, it's based on 2D imagery, but you mentioned about 3D models. So why would you use BIM over simple CAD drawings that are 2D actually typically in terms of the output?
Okay, and actually it is quite pity because we don't have too much time. Actually, the information that we can get from the full plan drawing is only the categories and the dimensions. But for the other informations were also from the section drawings. So we're thinking about after that, we can apply the more informations from the section drawings, like the height of the levels and the height of the like the wall and the windows and the locations, so we can combine them together. So basically at this stage we can only focus and finish of the full plan drawing.
Mm-hmm. And are you arguing that maybe in the end we do not even need any more 2D drawings? Maybe your tool could help us to self-configure BIMs that ultimately don't require 2D drawings after all, and you might even inform the contractor about the outcomes straight from a 3D or from the AI. Yeah. So you don't need architects probably anymore at all either.
Well, because now we're focused on the very standard 2D drawings. So in the long run, we may thinking that maybe in the future for the architects, they can draw them 2D drawings on the paper, then recognized by the deep learning, so they can immediately show the design to the client more quicker. Then they doesn't need any special tools.
Okay. Tom, you've joined us. I've seen it. Do you want to jump in with a comment or a question at this point?
Thank you. Yes. I was very struck in this paper and a few other papers about how we are creating tools to almost reverse the process. So while we've created in BIM sophisticated 3D models, here we are dealing with the dumbest of 2D drawings and trying to infer semantic back into them. It relates a little bit to the discussion earlier. Is there too much data in BIM? It's just, who's the audience? So when the audience is highly sophisticated, we can put an awful lot of information in and give them a lot of tools. And yet often the audience is much less sophisticated perhaps, or they just need less information. And therefore, what are we trying to represent? Some of the very earliest object modeling, which was proto-BIM, allowed different levels of representation. I'm struck by the fact suddenly this whole conversation has flipped from 15, 20 years ago, where we were trying to simplify the complexity to display it. Now we're dealing with the simplicity and trying to infer the semantics back into it. And I think that's probably a reflection of reality, in that it goes back to, I think, the paper that had been talked about, the one that the last paper where Veronica, I think it was, where most of the users are using it with the training wheels on. They're using it at the simplest level because it's just practice hasn't caught up with that. So this is a very interesting counterpoint paper to some of the other discussion.
Thanks, Tom. In the interest of time, we're going to move on. Thank you so much. I want to bring up Pavel and Clara with their work. And now we're actually expanding from the sort of building scale, and we're entering more sort of the urban scale, obviously. Maybe you two could talk about your papers jointly, because I think there are a lot of parallels and connections. And again, please don't see this as an invitation to represent. It's just really some of the key points to pick out in when we start to move up in this sort of urban scale, and when we look at sensitivities from the public, but also from councils, and the way your tool and your approach and your research can help councils to understand the impacts of new developments. Do you want to talk about that a little bit?
Yes, of course. Thank you very much. Do you hear me?
We can hear you.
Can you hear me? Yes, okay. So the goal of our research is to, as you said, investigate the impact of new investment into the cityscape. We deal with historical dominance, and we are the goal of my research is to support planning of new investment in historical landscape in terms of the impact of exposition of historical dominance. So I use viewshed analysis and simulation from human eye perspective, and to investigate what is the real impact of new investments into the cityscape. And Paweł?
Hello, Paweł Rubinowicz. Good morning and good evening, everyone. And my part of this research is going to focus on protection of strategic views, protection of the heritage actually of the cityscape, and it's very simple, just to define maximal height of buildings in the city in such a way that they will be not presented from strategic views that you would like to protect. And the study presented in the paper and in the video includes also some optimization of application of the VPS method, including different aspects of model quality, VPS resolution, and selection of strategic views for those analyses.
Thank you. We have already a comment or remark, and you might want to respond to this in the chat, which talks about the fact that in this case, you don't really need all that in-depth data, it seems. And there was a question about any semantics required for this particular field of investigation. I can tell, well, actually, no, I can't tell, but I wonder in how far the crossover now here happens clearly with GIS, geospatial information. I understood there is then a range of different you deal with a lot of very large data sets, I think, and a lot of what people in that realm and across the entire session, I feel, are grappling with is in how to simplify some of the geometry at times where it's not needed, but then again, focus on the geometry where it is needed. And so I wonder about the sort of interface between the GIS aspect here. And again, coming back to the other question about the semantics, what semantics might be required. So how informed do these environments need to be, or is it just purely a mapping of results based on their height?
Actually, in both cases, in Clara's and my research, we use digital surface model as a constantly mesh. It's really very complex data, including a lot of points, a lot of triangles. But we develop software in C++, which allows us to use model in the full quality as well for very large city areas. In fact, the semantics is here not so important like the quality of the model to get a real influence and real simulations important for urban planning.
Thank you. Thank you very much, Pavel. We will be moving on. Looking at, I think this time it was about green spaces and the detection and an automated way of detecting green spaces in different sort of urban settings. Could I invite Juju Lun and Siju to talk to us about this? And maybe could we also then have at the same time or a bit of a conversation with the paper by Yishi Chia and Yoshi and Tomohiro, because I feel that you are looking at there are some similarities, at least in how you address, well, not how you address, but what it is that you're addressing, but you seem to be addressing it from very different perspectives. One is much more from a top-down sort of maps, Google Maps and so forth sort of perspective, whereas the other one is much more from a people's view. Could we have a bit of a conversation about these approaches and how they might be complementary or yeah.
Oh, okay, I'm Zhou Juelun, and in this paper we quantify and analyze the spatial characters of urban form of 8 Chinese cities. First, because the 3D building information of the city is too large, so we choose another method. We'll classify the urban form from the satellite map based on classification from the meteorology. it means that the local climate zone system. This method can classify the urban form based on the built height and density and so on, to classify the urban form like some open mid-rise, compact mid-rise, and water and gray and so on. And then we quantitate the urban form by the landscape pattern indices. And the results shows that the urban form characters of each city are different. And there are 8 indices can help us know the spatial characters of the urban form. So that's the mean of this paper.
Thank you. And could I have some further points from paper 28?
Yes, hello. Can you hear me?
Yes, we can.
Can I share my own screen to make a briefly introduction?
No, we won't have to. Unfortunately, we will not have the time for everyone. If we started this, we might.
Thank you. Okay, I will make an introduction with this. And hello, everyone. I'm from Division of Sustainable Energy and Environmental Engineering of Osaka University. And my paper's title is Development of an Urban Greenery Evaluation System Based on Deep Learning and Google Street View. And the most important things of our research is we focus most on the urban street levels greenery quality estimations. And in our research, we develop a method based on the semantic processing of street view images to calculate the green view index of urban street level greenery. And by carrying the street view images through Google static street view API and then input these images into the pre-trained deep lab V3 model, we can obtain segmentation output, which contains like 90 catalogs shown in the pictures, which include the roads, buildings, vegetation, sky, cars, and which are the urban design elements. And after that, we validate the results by comparing recognition method, and the coefficient is up to 0.98, and which indicates that the GVI values calculated using the 2 different methods were quite similar.
Yeah,
so
I have to. Yeah, I want to.
Our research. Thank you.
Me. Yeah, oh, fantastic. Could we try and have a bit of a conversation here? Because I think this approach to me feels somewhat more qualitative in the sense that you get this person's perspective, whereas with paper 173, it seems a bit more, qualitative, whereas the other one seems more quantitative from the sort of approach. Is that a fair assumption, or would you see this differently?
Because of the internet connection, did they have some troubles of that?
Okay, now don't worry about this. We have actually a specific question from Patrick here, and that is how specific, and that's probably for both, really, that's a good question for both of you. How specific are your methodologies to the particular city typologies? Would require a lot of modification if, and Patrick asked particularly for Singapore, if this were to be applied in Singapore, in your case, would the tool need to be modified?
Yes.
Well,
and what? Sorry.
I think here we have some audio trouble with you. Tom, do you want to jump in with a comment?
Well, I think this is a very interesting question from Patrick, because one is a satellite image and therefore a footprint of the geometry of trees into the fabric of the city. The other one is a cone of vision perspective, and a cone of vision perspective is always forward. And Patrick's question about Singapore is interesting because the top of your head experiences something different from either the footprint or the cone of vision. In other words, different qualities of a city are experienced in multiple ways. Here we're seeing really a discussion about the photogrammetric representation, the visual representation of two environments. And yet, when it comes down to specifically the issue of trees, it's actually a skin sensing that is important. So the skin sensing is represented in neither of these two representations. So they're interesting technical discussions, but when you come down to the sensorial experience of a city, neither of them actually addresses that particular question of what's like to have the sun shining and you're searching for the shade from a tree.
Thanks very much, Tom, for your provocation or interesting points. It's probably not quite a provocation, but it's certainly a very good sort of insight that hopefully will enrich the researchers' sort of future work. We have to move on. We have about 9 minutes left, and I'm being, as I expected, I'm being bombarded with countdown sort of messages, which is always fun. Of course, we still have a number of other papers all dealing with sort of the urban sort of context. Maybe just looking at the order that we had, I would like to start with Wolfgang and Gabriel, and a quick, a very brief conversation. I think it's still early days for your research, and I think it's geared towards two different stakeholders, one being like citizens and the other being council and statutory sort of agents.
Yeah. Hello, everybody, and it's good to be here digital way. Just two aspects of our project. As you mentioned, it's at the beginning, and we focus on two fields. The one field is visualization, because we are dealing with proposed changes to land use and zoning plans, and the representation of these changes are 2D in 2D plans and in text form. So it's hard for an untrained people to understand what happens. And the first step is just to visualize it in 3D and quickly visualize alternatives, as you can see here in red. This is one of the proposed changes for a spot. And the second thing is to use the same setting for simulation so that we can see what is the effect of this implementation or of this change to the neighborhood. What is the change to visibility, to solar radiance, and all these things. So it brings together some of these papers that we already heard about, and above all, what is interesting for us is we want to use open data and open source programs. Therefore, we used Three.js for a moment.
Yeah. Have you considered, and I will do a bit of a crossover now with one of the other papers, looking at some of the environmental or daylight impacts on some of the solutions that you are suggesting? Because we have a very interesting sort of contribution here, and I'm asking Han or Surli or G or Patrick to jump in with yes on this one as well. But maybe give Wolfgang a quick opportunity to answer that question, and then jumping over to you.
We have a lot of things on our agenda, and one of these are, of course, the irradiance mapping and all these things. We started with the site analysis. What is important for a site analysis, and bring that into the different kind of models. So we have experience with other programs we used, like NetLogo and so on, for wind simulation. And now we want to bring all these things into one environment so that we can see.
Thanks, Wolfgang.
Yeah, sorry.
Thanks very much.
Right, should I
yes, please. Yes, talk to us a little bit.
Hello, everyone. Jolie, someone from Singapore, written paper together with Hanje, Zhangji, and Patrick. So Patrick's on the call as well. He's been asking questions. So our paper is basically dealing with a large set of data, in particular, the whole set of building data in one metropolitan, for example, Singapore. So what we did was for each building, basically, we created its own context geometry sets, and we've used the ability to process, to parallelly process geometries of Houdini's ability to do that. so that what we actually ended up doing was for each building and its set of neighboring geometry will be one, little simulation by itself, and at the end of the day, combine all the results together. So the whole process was enabled by procedural dependency graph feature of Houdini, and this could be carried out in a server farm kind of environment. So you don't have to rely on your local computer's processing power. The whole process could be paused. It could crash, and you could continue from where you stopped. And the geometry is in CTGML format, which is lightweight and very commonly used in city planning. Actually, quite a few of them are available to the public. Yeah.
And I feel, and Patrick also chipped in with a comment, I feel that these type of large city models, you really want to do some good householding on what data you need and what data you don't need. I remember you talked about this cling wrap type of minimizing certain geometric features that are not needed in a certain distance. And I found that also quite interesting, how you approach, how you look at taking out sort of detail that you don't need in several ways. So I would love to talk a little bit more, but with just a few minutes left and the need to really have everyone sort of included, I want to move on and maybe touch on your colleagues' work here in also, and I think this is Pradeep, Hanje, and you were also involved in this, I believe. So this seems to be a little bit more automated, let's say. It reminded me somehow on Patrick Schumacher's early sort of parametric type approach to developing cities. And I actually had a question about this one, in how far you allow for emergence to occur, or particular, let's say, if there were a cinema, a school, or some sort of attractors that would change, would that be able to change the fabric? Because ultimately, if you don't have that, you might end up with a lot of regularity and repetition. So I'm putting out a bit of a provocation on this paper. Somebody might want to.
Pradeep, are you going to answer that one?
I was about to explain the node, what we have developed. Yeah. So with our procedural modeling using Houdini, we had developed the fabric with the primary nodes and as well as secondary nodes, primary nodes being transit, and the secondary nodes could be basically amenities or the ones that you have mentioned. And it can surely identify such nodes and create such a different fabric along with the fabric what we already try and implement for the TOD sort of development.
Well, I think, Dominic, you actually hit the issue there, is where is emergence in all of this? The key thing about regulation is that it is put in place by those who want to stop the emergence from occurring. They want basically to control the outcome, yet they don't understand the detail of the experience of a city. So planners suffer from that issue. So when you write programs which are driven by the regulation, they being deterministic, leave out all of the opportunity for human habitation, essentially. That's where the other work earlier from Vienna was very interesting, because it allows you to explore the parameters and then play with it. Now, I know that in the Singapore case that we're just talking about, the user can interfere and manipulate, as you described. But there's a huge difference between manipulating the few parameters and allowing for the exploratory design emergence to occur. And that's one of the great fears of these tools, is that they generate the predictive outcomes rather than allowing us to see where the parameters might be broken.
Thanks, Tom. Absolutely right. Lastly, I want to quickly invite Anna to talk about her paper together with Lisa Marie about Berlin. I always like it when cities have these sort of gaps and leftover spaces, if you want, and it seems Berlin has quite a few of those. So very briefly, do you want to touch on how for whom is your tool ultimately? Is it for government? Is it for how would anyone, who would use your tool? Maybe that's the quick question from my end.
Hi everyone, thanks for having us. Well, we as students are highly affected by the housing shortage in Berlin at the moment, and that's why the only options for cheap accommodations basically are moving in the outskirts of the city. And that's something that's not very attractive for young people, and also not for the people who were living in Berlin for a very long time, but now can't afford rent anymore, to be driven in the outskirts of the city. And that's why we wanted to show the public, but also architects and planners in a more simply way, where there is still room for interventions in the city. Because at the moment, it's quite hard to do all the analysis for each plot on its own.
Thanks very much for your comments, Lisa Marie. Does anyone have a question you wanted to ask or a comment on the work? I know we are pretty much out of time, but maybe we can still sneak. I'm not sure if the system will shut us down. I'm sort of afraid if you don't see me anymore in a minute, it wasn't me. Do we have any comments or questions here? Patrick, I think you're on mute. Unless you're talking already to the next session.
Hi, yeah, can I ask a question?
Sure, of course.
So, so just to understand your platform, is it a web-based platform? Can people use this from a web application?
No, at the moment, unfortunately, it's coded with Grasshopper, and we haven't found a platform to share it. But yeah, it's still work in progress, so we're working on it.
Okay, great.
Well, if we don't have any final questions, and really apologies if this was all a bit rushed, and I wish we could be grabbing a beer somewhere together. I believe this is wrapping up today's session, at least from this stream. I've been asked to remind you about and invite you to tomorrow's keynote from Takeshi Yamada from TeamLab in Japan. So please all join us online. When I say tomorrow, of course, we never know where you are, so it might still be today. It was a really interesting session. I think, again, the material that we've seen just showcases how diverse this field has become, how we are dealing with really like with large data sets in the same way in an urban scale as we deal with large data sets on a BIM and building scale, and questions about semantics have come up quite a bit in how far we need to have, how much data do we need to have in those models to make them perform the things the things we want them to do for us and give us the kind of feedback we hope to gain from them. And how do we sort of household with that data, but also how can we use different computational approaches to extract different types of information, which I find quite interesting. And are we then using those to go back to our hand sketch one way or the other, or is it the other way around? Really interesting questions. I'll probably have to think about that over a glass of whiskey. It's getting late-ish in Melbourne, but I think for many of you, the day's about to start. Does any of our panelists still want to have a burning comment before I close this session? Not really? Thank you. In that case, thank you very much. It was great having you all in this session. I hope to see you in some of the other sessions tomorrow. Apologies to our non-panelists that I wasn't able to bring you in with a lot of questions unless they were asked via the chat. It's just simply a question of time with 45 minutes. I couldn't have done this otherwise, but I hope we had a good run-up from everyone. And
I could just say that maybe if people want to chat, we can go to the spatial room. The spatial room where you can talk to each other.
This is now very esoteric. So we are going to the spatial room.
Yeah,
spatial chat room. Let me inform you guys. Okay, let me get the link for you. So I just choose one room for you. Let's go to Cadria 25th anniversary exhibition. Okay, I will put the link in the chat.
Yeah, if you could give us the link and then we can see what we can
Actually, the links are, there are 3 rooms in the on the conference program, but I just choose one room so everybody can meet here on the Cadre 25th anniversary special chat. You
Fantastic.
just need to go with the browser.
Okay, thank you so much, Rajapan. Thanks so much to the conference organizers, and I look forward to see you either in the spatial room or at tomorrow's keynote. Thank you very much.